Assalamualaikum and hi, my name is Nuraisha Azirah Binti Hazam. Today I'm going to present about my final year project with the title Comparative Methods of the Large Scale of Missing Data Treatment. My supervisor in this project is Dr. Nuraisha Binti Tukiman. So these are the outline of my presentation today. I'm going to start with the introduction, literature review, methodology, result and discussion, conclusion, and lastly will be the recommendations. As for introduction, there are four main points that I've listed out for the introduction for this project. First, a complete and reliable data is required for water resources planning and management. Second, inaccuracy of hydrological modeling were affected by non-continuous time series precipitation inputs. As mentioned by Monjo et al. 2015, rainfall analysis is very crucial as rainfall data represent the key input to watershed models. So, there will be 5 selected methods will be used to compare the estimation of missing rainfall data. The problem of statement in this project are missing data effects on the quality of results in hydrological studies as well as water resources management as mentioned by Ahmed Aib et al. 2019. So, the size of missing data were affecting the accuracy of the climate analysis. Various methods were tested for the large scale of missing data treatment. The aim of this study are to determine the best method to be used to calculate the large scale of missing rainfall data. The objectives are to classify the size of missing rainfall data for the weather station at Terengganu. Second, to determine the best method in treating the large scale of missing data. The scope of the study for this project is, first one is the area of the study. There will be 7 rainfall stations in Terengganu State. Second one, there will be 5 methods will be involved in the calculations of missing data, which are first, using arithmetic average AA, modified normal ratio MNR, multiple imputation MI, expectation maximization EM, and the last one is inverse distance weighted IDW. So all these 5 methods will be compared and selected as the best method for the large scale of missing data. As mentioned before, the study area in this project will be at Terengganu State. So these are the maps of Terengganu State, and the 7 rainfall stations involved are located at first, Klinik Kampung Raja Besut, Sekolah Kebangsaan Kampung Tembila Besut, Institut Pertanian Besut, Sekolah Kebangsaan Kampung Jabi, Ibu Bekalan Sungai Angga Ulu Besut, Kampung La and Kampung Kerua Ulu Besut. The significance of study for this project is first, to minimize error of hydrologic modeling in Terengganu. Second, the missing data will influence the accuracy of climate prediction to find the best method to treat missing data, which to help to determine the long-term changes of trend of the hydrological pattern. For literature review, there are 5 points that have been selected that are talking about the missing data. First, as mentioned by D. Lewis et al. 2010, rainfall dataset may contain missing values which are due to malfunctions of instruments, bad weather, or human error during data entry. Second, by the Cho et al. 2017, amount of missing values directly decides the data quality. By Colibali and Evera et al. 2017, studies in many countries reveal that the rainfall analysis is very crucial as a major factor influencing flood formation. Fourth, by Ramos Calzado et al. 2018, the presence of gaps in the observed series of precipitation has been an old and well-known problem but difficult to solve. Last, by Trigavarapu and Chanamuli, studies based on rainfall data could be disturbed by the occurrence of missing data. Therefore, studies of procedure and methods used to estimate missing data are essential. There are also 5 points mentioned about the methods to treat missing data, which first, by Domonokos et al. 2015, the advantage of using the IDW is they are the simplest method, which is based in the assumption that the rainfall values at the target station could be influenced by nearest stations. By Juning et al. 2012, the multiple imputation is unlike single imputation. It doesn't allow additional error and far more suitable for the large missing data analysis. Third, by Romero 2013, The findings indicated that the CCW method was found superior than the traditional IDW in interpolating the missing landfall values. Fourth, by Kauti Henry George et al. 2015, the AA and MLR methods may be used in large scale of area with similar elevation conditions. Last one by Paulus 2010, the examinations of the result shows that SIB, LR and UK methods have minimum accuracy among all methods under the study. So here's the methodology for this project. First, we will receive the rainfall data from the JPS. Next, I will classify the scale of missing data, either it is large scale or small scale, and then they will be undergo the missing data treatment by using 5 selected methods, which are arithmetic average, modified normal ratio, inverse distance weighted, multiple imputation, and expectation maximization. After done all the treatment, they will be undergo the statistical analysis process to determine the most accurate method among all 5. So this is the first method, arithmetic average method, AA. The explanation about this method is missing data is obtained by computing the arithmetic average of the data corresponding to the nearest weather station. The formula given are V0 equal to summation of Vi divided by M, where V0 is estimated value of missing data, Vi value of same parameter at I nearest weather station, and N is number of nearest station. The second method is modified normal ratio method, MNR. This method is used by replacing the distance with the correlation coefficient as the Weighing value. The formula given are V0 equal to summation of Vi times Wi divided by summation of Wi, where Wi is the weight of I nearest weather station and Wi is given by the formula, which are equal to Ri square multiplied by Ni minus 2 divided by 1 minus Ri square. So Ri is the correlation coefficient between the target station and the ith surrounding station. Ni will be the number of points used to derive correlation coefficient. The third method is inverse distance weighting IDW method. This method weights neighboring stations on the basis of their distance from the target station on the assumption that closer stations are better correlated than those farther away. So the formula given are V0 equal to summation of xi over di square divided by summation of 1 over di square, where di is distance between target station and the ith neighboring station. For this formula, it requires us to choose the neighboring stations which are closer to the selected station. So I choose radius of closest station with less than 50 kilometers. The fourth method is multiple imputation method, MI. This method is done by replacing missing data with substituted value. Multiple imputation is essentially an iterative form of random imputation. This includes any transformations to variables that will be needed to assess the hypothesis of interest. There will be 7 steps to do this method. First, to impute the missing values by using an appropriate model. This incorporates random variations. Second, repeat the first step 3 to 5 times. Third, perform the desired analysis on each dataset by using standard complete data methods. And fourth, average the values of the parameter estimates across the missing value samples in order to obtain a single point estimate. Fifth, calculate the standard errors by averaging the squared standard errors of the missing value estimates. And sixth, calculate the variance of the missing value parameter across the samples. And the last one, to combine the two quantities in multiple imputation for missing data to calculate the standard errors. So for the last method, expectation maximization method, EM, there will be 4 explanations about this method. First one is this method will be done by using the SPSS software. Second, each iteration of the EM algorithm consists of 2 processes. First, the expectation, which we call as E step, and the maximum likelihood, we call as M step. And third, In the E step, multiple entries are created in an augmented dataset for each observation of missing values, and then probability of the observation is estimated based on current parameter. Last, in the M step, regression model is built from the augmented dataset. So here the screenshots of the software, which the box here is the data that we key in this software, and after they will projected all data here until they iterated to get one value. So after calculated the values of the missing data by using 5 treatment methods, the values will be undergo the statistical analysis by using 3 methods, which are similarity index S index, mean absolute error MAE, and coefficient of correlation CC. All values will be substituted into the parameters, which are Xi is observed rainfall at neighboring stations, Xi bar is estimated value, and N is the number of neighboring stations. So here is the result for Klinik Kampung Raja Besut. I have divided the percent of missing into 3, which are 5%, 20%, and 17%, and compared all 5 treatment methods by using the statistical analysis as index, MAE, and CC. So as a result, AA method gives a closest value to 1, which is more precise for a lower percent of missing, 5%. MNR method shows lowest value with 0.77 for all percent of missing. Table shows MI method is the most precise value for all level of percent of missing with 0.93 and 0.99. So here is the result and several graphs of the treated value for station Klinik Kampung Raja Besut. On top left corner, there are table of months of missing and the year of missing for station Klinik Kampung Raja. From the graph, it can be seen that the yellow colored line represents the AA method. It shows that the yellow color is not following the other 4 methods. It gives a different value compared to the other 4 methods. Next is the result for Station Institute Pertanian Besut. It also divided into 3% of missing, which are 5%, 20%, and 70%, and compared all 5 treatment methods into statistical analysis as index, MAE, and CC. As a result, the value in this station less precise with average of 0.6 to 0.88 for methods using S index and CC. For 5% of missing on methods S index, MNR is the lowest with 0.741 followed by IDW 0.811, AA 0.867, EM 0.873, and MI 0.899. Table shows MI method is the most precise value for all level of percent of missing with 0.83 and 0.89 value. It can be seen from the 3 graph S index, MAE, and CC. The methods AA are not following the other 4 methods, and the patterns are slightly different to compare from the other 4 methods. And here is the result and several graphs for Station Institute Pertanian Besut. So it can be seen that there are many years involved in the missing rainfall data. It may explain why the statistical analysis for this station gives the lower value with the highest only 0.89. As for discussion, the best method that shows the least percent of error is MI method with 0.01 to 0.1. Second, method EM and IDW show similar result. MNR method with a slightly different value, which is 0.6 to 0.8 compared to the other 3 methods, which are 0.7 to 0.9. And the last one, AA method are giving a larger values for 20% and 70% of missing, which are 0.4 to 0.6 compared to the other 4 methods, 0.6 to 0.9. So as a conclusion, the size of missing rainfall data in Terengganu are determined. So 43 rainfall stations of Terengganu and each of it facing a problem with large amount of missing data. According to the statistical analysis, all four methods, which are MI, EM, IDW and MNR, are suitable to be used to calculate the large scale of missing data. AA method is suitable only for a small scale of missing data calculations. The best method used that gives the closest value is MI method. So that is all from me. Thank you.